Hey, yeah. Hello, everyone. Thanks for joining us. Come on in. Um, we're very happy today to welcome Dr. Erik Biljeveld. Erik obtained his PhD in 2012 from Utrecht University, where he started working on unconscious and conscious processes that shape performance when people are in pursuit of monetary rewards. There, he originally worked with Ruud Koesters and Henk Arts. He stayed there for a couple more years as a postdoctoral researcher and moved to Radboud University in 2014, where he first was assistant professor and currently holds the position of associate professor at the Behavioral Science Institute. His research is very much focused on the interplay of motivation and cognition. For example, he investigates how and when incentives can distract people from their ongoing activities and how fatigue affects people's decisions. He conducts both a rather basic experimental work, but also more applied field research, where he looks at the role of motivation in sort of more real life settings. And yeah, we're very much looking forward to hearing about some of your work today. We really appreciate that you came all the way to Dortmund today, and we're looking forward to your talk.
Well, thank you for having me, Laura, and all colleagues. Today, I would like to talk about effort, fatigue, and distraction during mental work. What I will present today is mainly or mostly the work of three of my former students who have now worked on, Jonas, Pam, and Louise, yeah, but also my collaborators at Radboud and elsewhere. So the societal background of my talk is people's complicated relationship with technology. So we have come a long way since this picture here. This was in the late 70s. And you might expect intuitively that technology is there to make work easier. All right, think about large language models nowadays. I think if you think about it, they should be able, these type of technology should be able to make our work as researchers more efficient and more easy. But if you look at what happened historically, this is not the case. Right? For example, one problem with the development of new technology is that it tends to higher performance standards. So if there's a new technology, then also the bar for performance goes up and people have to produce more or expected to produce more. And another challenge is there that when you replace certain tasks that you used to do yourself by some new technology, then usually the tasks that remain are not necessarily easier or less demanding than what was there before. So the rise of new technology is not necessarily something that makes work easier. If anything, historically, it has made work more demanding. Now, against the background of this development, I will talk about what are the costs of work, or at least the subjective costs of work. And I will talk about feelings of effort and feelings of fatigue that are likely to emerge, right, when people do high demanding work in real life, but also in the lab. So the first project I'd like to talk about, that I want to talk about today, is a project about the unpleasantness of mental effort. And this is something that has been quite a lot of debate about. And you can say, yes, mental effort is something that is inherently unpleasant. But you could also say, okay, this is not the case. Under some circumstances, mental effort can actually be enjoyable. And we aimed with this project that I want to talk about to contribute to this debate and look at it in a new way. So is mental effort inherently unpleasant? Well, you could say, yes, it is. If you look at the old work by Clark Hull, for example, and Tsai in China, then people do tend to avoid or try, when people get the choice, they do pick choices that take less effort. And this is called by Hull mentioned, named is the law of less work. Well, that tends to hold up empirically. And you see that also now in our lab, but other labs in the world also have shown it many times. Another reason for why mental effort might feel unpleasant is that models of cognitive control assume a role for negative effort. So, for example, this is also a very European and German thing. So, for example, David Dignet's work in Tübingen and Gesine Dreisberg's work in Regensburg, they all assume some role for negative effect when people exert cognitive control. So, with mental cognitive control being effort, well, it follows that that might also feel unpleasant. A more interdisciplinary way to assume that that mental effort feels unpleasant is to look at economics and neuroscience, where if you look at computational models of effort or of work in general and applied economics, then effort is often modeled as a cost. So something, a quantity that people tend to avoid. Right? So there is an argument to make. It's a small step from there to thinking, okay, if it's a cost, if people avoid it, if negative effect is involved in cognitive control, then exerting mental effort might be inherently unpleasant. The other side of the debate comes from other strands of research in psychology. For example, the idea that effort can become a secondary reinforcement. Right? This is an idea that's also older. It traces back to Eisenberger, but nowadays there's also a few new studies from Austria that also show, well, that at least you can train people, teach people to choose high effort options. Another idea that some of you might be familiar with is the idea that people vary in a need for cognition. This goes back to a questionnaire developed by Cacioppo in the 90s that shows that people vary in the degree to which they agree to statements such as, I enjoy solving puzzles and I like my work to be challenging. Right? There's large variation in that. Some people, when asked, indicate that they like exerting effort, or at least that they like performing effortful tasks. Now, broadening up a bit more into anthropology, there's also several religions out there across the whole world that say in different terms that, that exerting effort is morally pure. Something like this exists in Protestantism, but also in Islam. If you earn money through efforts, this is something that's a good thing. And through that association that people might have learned in their upbringing, you might assume that, okay, some people might get a positive association with effort, making it feel nicer. And then there's a more practical anecdotal point, which I summarize as millions of people play chess. And maybe you know this from your personal life. People do tend to seek out effort for it. So we have this debate here in psychology where two sides of the story both can be true. At least there's viable arguments for both. Effort might be inherently aversive, but it might also not be the case. You might be able to teach people or train people to enjoy effort. Now, what we have done here is try to look at this from a different angle than had been done before. The previous angle was, I think, more experimental. We asked these two questions. Is mental effort generally experienced as aversive? And what sample and task characteristics moderate experienced aversiveness of effort? And we have done this with a meta-analysis in which we used a questionnaire called the NASA Task Load Index. And well, this being an ergonomics department, I think many of you might know it. It's a questionnaire that has a couple of questions in it. One is about effort, and the question is, how hard did you have to work to accomplish your level of performance? And there's also a question about it, an item on it, on negative effect, and that's how insecure, discouraged, irritated, annoyed, and stressed did you feel? Now, of course, I know these items aren't perfect, but they do give an indication of how much mental effort people expended during mental work, and also how bad they felt, how much negative affect. So these items not being perfect, I think a nice aspect of the NASA TLX is that it has become so incredibly popular in ergonomics and psychology. So by focusing on this instrument, and we're going to look at the relationship between these two items, by focusing on this instrument, we were able to capture a whole big range of variation of different things that people do in real life. And for example, we found this study from Poland where EMT workers, ambulance workers, had to identify victims in a VR scenario, and then they filled out the NASA TLX answer the questions. In a study from China, people played around with this new tabletop digital device depicted here. And then after doing that for about 30 minutes, they filled out NASA TLX. And then there was this study from the US where airline pilots completed like a medium haul flight, for example, between New York and Boston. And then after that, they filled out NASA TLX. So by focusing on this instrument, we have a wide range of situations, but a standardized measurement instrument after, allowing us to look at, well, the association between these two quantities, effort and negative effect, in all kinds of populations and tasks. Now, part of our meta-analytic method was also that we looked at a lot of moderators. And one of them, a couple of them, a group of them, stemmed from the idea that it might be possible to learn through your early upbringing or through education that mental effort is somehow pleasant. So it can be the case, for example, that at universities, people are usually rewarded for thinking hard, and for exerting mental effort. So you could say that education, well, maybe mental effort is less aversive for people who are more higher educated. And you can make also arguments about, for example, work experience, the fit between the tasks that people do in their training, and also continents and country, because there's different ways educational systems function differently in different parts of the world. In work psychology, there's also a long tradition of looking at different aspects of tasks, which we also coded. And the idea is maybe some tasks are more conducive to positive effect than others. Right? So maybe on some tasks, negative effect, mental effort feels less aversive than on other tasks. For example, if tasks are varied and if people get different types of feedback and if they have control or autonomy, and if the task feels meaningful to some outside event, for example, if you're teaching, for example, you are making an impact on real people as compared to, for example, a lab situation, you can say, okay, maybe these are the circumstances under which mental effort is actually nice. And then we also explored a couple of other things, age, gender, and so on. Physical activity also being one. You can imagine that if you stand up, maybe effort feels different than when you sit down. Now, answering these questions, we had 170 different studies with in total about 350 tasks, which are depicted here. And we find a clear relationship between negative effect and mental effort, or other way around, mental effort and negative effect. And with each point increase in mental effort, there would be a 0.85 increase in negative effect. And we also tried, and you see that in the background, we have like a curvilinear model, but that really didn't add much to it. So yeah, to the answer to our research question, if you zoom out very much to all these populations, then you find this association between mental effort and negative effect. Moving on to the sample and task characteristics, we looked at all these moderators I mentioned just now, and overall we found I was very surprised that there were so few results, right? So we looked within all the levels of all the moderators, and for example, we didn't find a difference between non-university and university students. In both cases, they are clearly positive. So in both separate populations, there's this association between effort and negative effort. If you move on, for task design, we also found that it did not matter that much. At least we found no evidence that it mattered. And for the exploratory moderators like age and gender and duration, also we found no evidence. The only exception to this pattern is that we found something interesting for the different continents. When we grouped this for the different continents, then you see a clear relationship for Europe and North America, but less so for studies conducted in Asia. So for studies conducted in Asia, it seems that studies conducted there was a less clear link between mental effort and negative effect. Maybe the implication could be that people in Asia have experience, perhaps due to their upbringing or their educational systems. Mental effort is less aversive than we do in Europe or as they do in North America. So mental effort felt aversive across all populations and tasks that we studied. We cautiously conclude that mental effort is inherently aversive. We have to be very cautious here for, I think, two reasons. One I mentioned already, which is the imperfection of these two measures of mental effort and negative effect, which is something we accepted because this allowed us to look at such a broad range of populations. The other reason is that I have to remind you this meta-analysis is quite zoomed out. So it's on the level of the sample. So the interpretation would be if a sample of people experience a lot of mental effort on the sample level, on the mean for the sample, that sample also experiences more negative effect comparatively. Right? We have no information of what happens within those samples. And there's some work, for example, by Timothy Bates in the UK, showing that this link between mental effort and negative effect is less strong, for example, in people who are more conscientious. Right? So I don't deny that within groups like these differences exist, but if you zoom out, then you find this very clear and strong link between mental effort and negative effect. You could also say this is a new piece of support for models that conceptualize effort as a cost. And so if you look at applied economics, well, it kind of makes sense that mental effort is at the cost side of this equation. At least when you zoom out, that's what people experience. And what remains is maybe the question, why do people play chess? That's something we thought about a lot. One way to think about this is that if you think of effort as a cost, then that there has to be like a dissociation between what people choose to do and how they experience while doing it. So if you choose to play chess, chess also involves all kinds of rewards, right? For example, playing with someone else, sometimes winning, the joy of mastering a new skill. It could be the case that these compensate for the effort. In our view, in our interpretation, we say, okay, that might all be true and that might compensate for the mental effort in that people choose to play chess and might enjoy aspects of chess. But the core thinking aspect or the hard work, the hard mental effort by itself might still feel aversive. Of course, this is our interpretation and we realize there's others as well. Okay, shall I continue with the next part here? Yes, is that fine? Okay. The next part of my talk is about mental fatigue. And this is, rather than the feeling of effort, is something I think that happens in the moment when people are doing a task. Fatigue is something that builds up time on task, for example, during a working day or within a session in the lab. So I have a background in cognitive psychology, but also I did a lot of reading in social psychology. And if you look there, then there's a strong history of resource models. And these models come from the tradition of ego depletion. You might have heard this term. And the idea is that when people feel tired or fatigued during mental work, this is an indication that their mental battery is getting empty. So it assumes that there's some mental battery in their mind, some metaphorical battery, and that when fatigue is there, well, there's one thing you can do, and that's rest so that it will recharge again. Now, in social psychology, but also beyond, I think these resource models have, they have been less well regarded recently because they're quite hard to test. And there are people who have been looking in the brain to find this resource. And it proved quite hard to find, right? There's not one substance, like, for example, glucose or oxygen, that's actually decreasing in the brain when people are, for example, doing a Stroop test or flanker test. That's something that's very hard to pinpoint. So models like this have been making way for motivational models that make a different assumption, which is that people continuously weigh the cost and benefits of their current activity versus the cost and benefits, for example, of the next best alternative. What I present now is the opportunity cost model by Kurzban, but there's other similar ideas out there, for example, by Leibniz-Institut. Now, the idea of this model is that, for example, for you right now, you're listening to me, this is your current task. It might have certain benefits to you. Maybe you learn some new things, or maybe it's otherwise entertaining. But the alternative task could be, for example, checking your phone or walking out here and doing something else, right? The idea, the prediction from this model is if the part on the left wins, if it's higher than the right part, this is when fatigue remains low and when people stay with the current activity. However, when the next best alternative has a higher utility, lower costs and higher benefits, then that should be the situation when people feel more fatigue and also tend to switch to a different activity. So deriving from this model, we have an experimental program that tests two theses or two predictions from this model. One is that fatigue stems from opportunity costs. So if opportunity costs are higher, so the cost of the thing you're not doing, if these are higher, fatigue should go up faster. And the other idea is that the other prediction is that fatigue predicts switches to alternative activities. So when people feel tired, they should be more likely to choose to do something else than they had been doing before. Now, we tested these two in a couple of experimental studies and field studies that I would like to show. Our experimental approach is that we had people perform a task in 40 segments of 2 minutes. So people came into the lab 40 minutes times 2 minutes, so 80 minutes in total. And at every 2-minute interval, they could choose to do either like a two-back task, so something that's mentally demanding, for which they would get paid money. right? So if they would do the two-back task correctly, they would earn some couple of cents per trial. So this increased their payments. But they could also choose to do 2 minutes something else. And that something else is basically the alternative activity that we manipulated to be more pleasant. In one initial experiment, and we are a bit more applied, so we sacrificed some experimental control here. We had people either read this retirement magazine, which we felt that we are student participants, and we assumed that this would not be so interesting to them because it's so far away, right? It's remote from their life. And the other condition, the more pleasant condition, the higher value condition, would be playing with their own smartphone. So these would be the two things we compared there. Turned out that these students did enjoy reading this retirement magazine. But then, in another study, we basically asked people to imagine doing a couple of activities. For example, playing with their own smartphone, writing a letter to a friend, solving a Rubik's Cube, reading a car magazine, coloring in mandalas, and solving a jigsaw puzzle. And then we asked them before the experiment to what extent do you like these things? And then we randomized them in 2 groups. And the lucky group would get their highest value activity, and the other group, the control group, would get their low value activity. So the thing they expected to like least. Importantly, in between all those 2 segments, we asked 40 times how fatigued do we feel now. And this is an item we know, this is like you would do in ecological momentary assessment. This one item we know correlates about 0.8 with longer scales of fatigue. So we asked that item 40 times. Now, to the findings. So does having a more attractive alternative task increase fatigue? Well, the answer is, well, on first sight, this was not something that we find consistently. So in study 2, this is a study where we contrasted the retirement magazine with the phones. And this is a study where we individualized the tasks. We find no difference in fatigue. So here you see the change in fatigue over time between the one block to the other block. 1 block of 2 minutes to the next block. And you see that it's positive in all cases. So this is during the two-back task. Right? So during the two-back task, people did get more tired, about 5 points on a 100-point scale in both studies. But there was no clear difference between the 2 conditions. So here we find no evidence that increasing the value of the alternative activity increases fatigue faster than not having that. So this was somewhat puzzling to us. So here are the coefficients. Another thing that I think is interesting is that we also found that people had really no idea if they were going to like something or not. So this is the study 3, where we asked people beforehand, what were they going to like? And there was a clear split between the thing they liked least and the thing they expected to like most. Right? So this is what you would expect, because they were like manipulated in this way. This is the high value treatment and low value treatment. Of course, this is how they were selected, so you expect it. After the experiment, you find that this is much more mixed. So you find a lot of people here who, for example, here very much expected to like playing with their phone, but afterwards they reported not liking that at all, really hated it. The other way around, they expected not to like all these things, but for a substantial amount of people, people did afterwards enjoy all those things, right? So this variety lets us basically to assume that, well, maybe this is, of course, this is something that might change over time, especially when it serves as a contrast to do something like a two-back test. Then that thing becomes enjoyable. So what we did then in turn, and this is where we do find a robust association, is when we look at this correlationally. So what you see on the x-axis here is the enjoyment of the leisure task, rated afterwards. So we asked afterwards, how much did you like this leisure activity? And on the y-axis, you see again the change in fatigue. And there's 2 findings here that I think are interesting. This is the orange line is what happened during two-back task. And you see that it slightly slopes up, right? So when people were doing the two-back tasks, people got more fatigued overall because it's above 0. But this is more so when there was also something as an alternative activity that they liked more. So that's one finding, and this is in support of the opportunity cost model, even though it's post hoc. For the leisure task, we did find that when people had something they enjoyed, and this is in line with work psychology, when they did something they enjoyed, they recovered faster from fatigue. So this pattern is exploratory and correlational, but we did find it 4 times in 4 different studies. So we do take it as some initial evidence for the opportunity cost model. Okay. Yeah, patients. So there are 2 theses here that I mentioned earlier. Fatigue stems from opportunity costs. For that, we find like some evidence, but only correlation, not experimental. In these studies, we do find very clearly that fatigue predicts switches to alternative activities. And we find this mediation that when people have been working on a task for longer, they report more fatigue, which in turn predicts them more often choosing leisure activity. So in experimental settings, we find this very clearly. What I wanted to discuss now is also the same prediction, the second one, that fatigue predicts switches to alternative activities, but now from our field studies. So this is something we took also to the field in several studies, and I will show you a couple of those now. So in this project, we were interested in phones, so in phone use in different populations. And we had a study among PhD students, and we had 85 of them. And they were all users of Android, and we installed on their Android phone, we installed an app that kept track on when they unlocked their phone. So across a couple of days, we had like minute-to-minute data of when they unlocked their phone. We asked them to take part in days in which they did not have a lot of meetings, for example, with their supervisor or their advisor or other teaching meetings, in which they had like free time to like basically decide on what aspects of their work to work on. And during those days, we asked them every hour, we sent them an email asking them to report how fatigued they felt. So we have 2 modalities. We have like the self-report modality from people's experience of fatigue during the working day between 8 and 5. And also what happened on their phone. And the idea is, well, if they are more tired, are they more likely to pick up their smartphone in the minutes after they answered the questionnaire? And for that, we find quite some evidence. So you see here a descriptive plot. So every vertical line is 1 person. And for each person, we made 2 estimates. One when that person was relatively fatigued, and one when they did not feel relatively fatigued, like one student deviation below their own mean. And you see here the probability of picking up their smartphone in the 20 minutes after the questionnaire. And you see for most people, the blue dot is higher than the black dot, meaning that they were more likely to pick up their smartphone when they were relatively high in fatigue. To make this more concrete, with each half a standard deviation, which corresponds with about 11 points on the 100 scale, participants became 1.4 times more likely to pick up their smartphone. So half a standard deviation increase in fatigue within subjects would be 1.4 times more likely to pick up the phone in the 20 minutes after. Okay.
Can I
Yeah, you can definitely, yeah.
Have you tracked, maybe that was too much of private information, but have you tracked which apps they're using? Is it work related? Because if it's a busy day, they feel high in fatigue and they're more likely to pick up their phone.
Yeah, it's a great question, and it does come up sometimes. So yes, we tracked it. No, we haven't analyzed it.
Okay. Do you have any idea on that?
What we did, what the ideas that I do have, that the phone they had was their private phone, and they did so in the instructions and the informal reports, at least in the inclusion criteria, the idea was that they would mainly use their phone for private matters. But of course, there might still be variation. Yeah. Okay. Moving on. Another way in which we looked at this, and this is a bit more remote from what I've been talking about before, is our work on sitting behavior. And we studied this, and this has been a long-lasting desire from me and the people around me to study sitting from a works perspective, because it's such a big public health risk. Right? Our world is designed to sit. All of you are sitting right now, but it's something we know is not so healthy to do in long stretches of time. You probably have heard the phrase "sitting is new smoking," and we have a project on that where we collaborate with the university hospital, who have these very nice wearable devices that you stick on the upper leg, and it tracks the posture during the entire workday. You see people nodding. Maybe you have them too. It's called active PAL devices. If you look at data, what people look like, these are typical desk workers from the UK during their working day. And you see that every line is one person. And you see that all the red segments are when they were sitting during their working day. And you see what's like a big ocean of red. And it's also something that's hard to overcome, right? If you give people like a standing desk, we know that works for a while, but then it wears off, and then people put it on a low setting and keep it. So we try to study this, and one thing we try to do is basically come up with a new way to analyze these data, and that was what we tried to do in this project. So what had been done before in this project was often to basically collapse sitting time to collapse rich data like this to like one number, which is the number of hours people sit in a day. And we thought, okay, there's much more in there. All these traditions, all these transitions are like individual behaviors. And we thought, okay, maybe it's nice to analyze these individual behaviors rather than like the accumulated total sitting time. That was the main premise of our project. One of the findings that we did consistently, first in a sample in the UK, and then also in a sample in the Netherlands, which were quite different, but both were desk workers, is that people switch back and forth between postures more often later in the workday, presumably when they are more fatigued. So we did not measure fatigue directly here, but assuming that people were more tired, then these switches became more likely. So I can show you if you are interested in this. I have quite some time. This is the model that we use. So the model that we used here is basically something that we took from medicine. In medicine, you have these models that are called survival analysis. And the idea is that they are used to analyze how long it takes until a certain event happens. Typically in medicine, this is death or recovery, right? And they have the statistical model for this. You also have a multi-level variant from this. And then you basically assume that you model the time to a certain transition, in our case, transition from sitting to standing or the other way around. You model when it happens and how long it takes for that to happen. And then in the end, you get like estimates like this, where we have modeled this. You see here, when people are sitting, so this is basically the amount of time that people, from when people are started sitting until they stand up again. Right? And you see in the top, basically is the probability of remaining seating, or the proportion remaining seating. So you see after 0 minutes, every sitting episode is still ongoing. After 120 minutes, all sitting episodes were gone. They stopped because people stood up. Right? And you see these curves, and you can basically interpret them like this. So if you look at 30 minutes, you see that in the morning at 9 p.m., about 18% of the sitting episodes were still ongoing. Right? So quite a lot compared to later on the day, namely at 5 p.m. It's about 10%. So this is how you would interpret it. So the probability of sitting episodes still being ongoing is a lot smaller than later in the afternoon. Another picture of this. This is a more exploratory picture that we made after we published the paper. You see that there's like, if you compare different types of sitting episodes, some are like very long, like the very unhealthy ones, the ones that are longer than 90 minutes. You see that they have this clear distribution that they happen in the morning and also after lunch, which is something that they happen. For the much shorter sitting episodes, we don't see that clear distribution across the day. Now, the overall point here is, okay, so when people are tired, this might serve as a signal to go do something else. And that's why they might like stand up when they were sitting. And that's something you would not expect, I think, based on the health psychology literature. You could say, okay, when people are tired, they just sit down and crash on the couch and do nothing and remain seated. Well, if that were the case, we would basically expect the opposite pattern. It's basically people relax in the afternoons. And we find that mainly in the mornings. So when people are most concentrated or most able to concentrate, that's when they are most at risk for this unhealthy sitting behavior. Let me see. I'm missing some of my slides. Wait a second. Where did they go? Here. Here. Yeah. Yeah. About my project on fatigue. So the fatigue project. So the take-home messages here are that fatigue predicts switches between different activities. Fatigue may depend on the reward value of the next best next value to next best alternative activity. And you could say that fatigue can be thought of or can be conceptualized as motivational phenomenon. This was the second line of research that I want to talk about. The last 5 minutes or so, I wanted to talk about where I want to go with this line of research. Is that okay? I've time.
Okay,
I know, yeah, I'm a bit short. Maybe I talk faster than I planned. So one thing I know, if I started reading the fatigue literature a bit more broadly than only in work psychology and cognitive psychology. And it has been studied in so many fields, also sleep science and medicine. And I think if you ask people where does fatigue come from, the answer depends very much on who you ask, right? If you ask a sleep scientist, they will say it has to do with slow wave sleep, for example. And if you ask me, I say it has to do with opportunity cost. And if you ask someone who studies medicine, they would say it has to do with inflammation, right? So this is, I think, kind of a scientific problem that we don't have a general theory of fatigue. But it's also, I think, a more practical problem, because if you go to a doctor and you say something like, okay, I've been tired for a few weeks, then that's also kind of difficult because they don't really know that well how to help you. It can have so many different causes, right? It can have so many different phases. So that's why also fatigue-related disorders are often very difficult to diagnose and treat, especially diagnose. One example would be chronic fatigue syndrome, which is often misdiagnosed. Same for burnout. Now, if we want to move away from this and maybe work towards a general theory of fatigue, I think we have to first start with appreciating that fatigue is a very dynamic and individual phenomenon. And I tried to make a sketch of this. I think if you look at like the basic neurobiological mechanisms and cognitive mechanisms that play a role, they have to do with sleep and with effort, like I talked about earlier, and also with tissue damage. So I think this corresponds to the different fields studying fatigue, so sleep and work and inflammation. But if you think about these, they can all be like part of I think, a bigger system, for example, a social system, right? So if you think about sleep, this is something that's highly dependent on your family situation. If there's kids at home in the night, then sleep is different. You can also imagine that tissue damage is also something that also comes from the family, right? So if people come into your household who are sick, well, then inflammations might occur, causing fatigue. So this is very much interrelated. You can also think about the broader work system around this. If you think about shift work, for example, all these work parameters, they constrain all these individual processes, I would say. So they constrain, for example, how well people sleep, but also when they exert effort and how often they can rest, right? And also there can be a source of infections. So the broader systems also affect these smaller causal processes. One thing that's also been neglected is this broader societal system around it. So, for example, we know that there's, for example, a gender gap in fatigue. Women reporting more fatigue than men. And also people, you could argue that people who are at the bottom of the organization also often feel more fatigue than people higher in the organization. So perhaps there are other constraints that come broader from societal systems. Another example would be people who are very low in income, have more things to worry about, worrying being something that's mentally effortful, also being a source. So the point being here is that fatigue is so incredibly individual and that there's many connections here and if you would draw a causal diagram here, it would be like insane. It would be something you hardly cannot do. So what you have to do is embrace the complexity here and treat this as a complex dynamic system. Now, this is very hard to study, and I think one thing we have done so far is basically trying to isolate these different parts of this complex dynamic system. And one example would be what I have just been telling you. I just only look at opportunity costs and basically claim that I understand fatigue better now by looking at this small part of the system, even though it's something that is only a small part of something much broader. So my approach is one way of doing that, but there's different approaches in science. Now, if all these connections exist, and they exist on different time courses, you also get like recurring loops, right? And then it becomes even harder to get this causal diagram. So what I suggest we do is, in order to understand such a complex dynamic system, there are ways of doing it. And it starts with looking at how this phenomenon or how this key readout from the system, in this case, fatigue, how it behaves over time. I have some data on this from a big cohort study that we did in Nijmegen. We had people for 6 days, they answered questions about fatigue 10 times a day on their phone. And you see that there's this general pattern that it starts in the morning, people are not so fatigued, and then it dips up till noon, and then it goes up and up and up. And this is something other people have found as well. So we replicate this. But the point is, if you look at the individual people that make up this average, this is the average of 100 people, the green lines are like 5 people who were randomly chosen. And this is representative for the population. So what we see here is that this average is really not representative of anyone. Right? So if we try to understand the average for fatigue, like I've been doing in the past half an hour, well, we don't learn that much. We are still not able to help these people. So I think starting out from these timelines or these time series analysis, that's something what I think could be like a way forward into working towards a more general view. That's, for example, also useful for medicine and sleep science. So wrapping up, I started out with the relationship between people and technology, and that well, more technology is actually might at work create higher mental demands. I described our new approach of looking at whether mental effort is aversive in all these different studies that we compiled in this meta-analysis, finding a rather robust or a very robust, a surprisingly robust relationship on the sample level between mental effort and negative effect, making use of the NASA task load index. Then I talked about our line of research on fatigue, where the resource models have been making way for more motivational approaches like the opportunity cost model. And there I showed some studies where we try to vary the opportunity cost of work, of doing mental work. And we found some evidence that opportunity costs matter, but not so strong yet. What we did find is that when people feel fatigued, for example, in our sitting project, they are more likely to switch to other activities. So part of the model is, I think, at least part of the model is useful. And then I sketched in the anti-outlook where I think fatigue science could go to. And this brings me to the end of my talk.